HOD, Department of EEE from DBS Institute of Technology, Kavali. Today I discuss about the one topic of the fourth unit of basic electrical circuits. So before going to this topics, what are the different topics in this unit and what is the basic unit of this system is, that is network theorems. What is the name of this unit will be network theorems. So under this network theorems, I have to go through about the what is superposition theorem and what is reciprocity theorem and what is Thevenin's theorem and what is Norton's theorem and what is maximum power transfer theorem and Millman's theorem and compensation theorem. So there are totally 7 theorems in your unit. So under that, what is the superposition, reciprocity, Thevenin's theorem, Norton's theorem, maximum power transfer theorem, Millman's theorem and compensation theorem. So before going to this network theorems, up to now we have seen that different techniques, different methods in AC and DC circuits. The simplification of the different techniques must be there. So you have to simplify the network in the form of the loop analysis or in the mesh analysis, or we have taken the source transformation technique and equivalent delta method or equivalent resistance we have to find out, and star to delta transformation and delta to star transformation, and then you have to use about the when you have to take in the loop analysis, mesh analysis, like that you have to simplify the techniques for finding the voltage and current. These theorems also, by reducing the complexity of that networks, these theorems must be very useful. So first in this day I want to discuss about the what is superposition theorem. So superposition theorem is, it states that for any linear bilateral network, the response of voltage or current in any branch of a bilateral linear circuit having more than one independent sources equals the algebraic sum of the responses caused by each independent sources acting alone. That means in the statement of the superposition theorem, if any linear network containing two or more sources must be there, more than one independent sources must be there, it equals to the algebraic sum of the responses caused by the independent sources acting alone. That means if there is a number of sources in the superposition theorem, that means if suppose there is one voltage source and one current source must be there, or if there is two current sources or two voltage sources must be there. So you have to consider one source at a time. Then the remaining sources must be non-operative. When you have to solve any problem in the superposition theorem, at that time you have to consider one source at a time and the remaining sources must be operative. That means if suppose the current source must be there, put it as open circuit. If there is number of current sources must be there, then put it as open circuit. Only you have to take in the one source at a time. If there is number of voltage sources must be there, put it as a short circuit. If there is the independent sources must be there, that means I already tell that there is the sources or independent sources and dependent sources. Dependent sources means the one source will be depend to the another source, then it is called as dependent sources. Independent source means it does not depend upon the any element, it is in the independent, it does not depend upon any other sources. When there is the independent sources are there, then first you have to consider one source at a time and the remaining source whatever there is there. If there is voltage source must be there, you have to short. If there is current source must be there, you have to open. If there is dependent source must be there, they should not replaced by open or short circuit. and must be kept as it so. So what as it is, what it is there, you have to kept as it is. Such sources have zero value only when voltage or current controlling them is zero. Such sources are taken as a zero value when it will be the dependent sources, when the voltage and current voltage or current controlling them is zero. So, superposition theorem states that in any linear or bilateral network containing two or more independent sources equal to the algebraic sum of the responses caused by each independent sources acting alone, where all other independent sources are replaced by the internal impedance. That means if there is a voltage sources must be there, put it as short. If it will be the current source must be there, put it at open. If there is dependent sources are there, there is no need to change that open or short. Very important point for superposition theorem. Superposition theorem does not apply to the power. It does not apply to the power because power is proportional to the square of the current, so which is not a linear function. If it will be, the superposition theorem will be the linear function. So superposition theorem does not apply to the power, as power is the square of the current, which is not a linear function. This is about the statement of superposition theorem. So how you find out the currents in the superposition theorem? What is the procedure to find out the currents or to solve the network by using the superposition theorem? So first, following these steps in order to find the response in a particular branch using superposition theorem. So first, step 1. Step 1. Find the response in a particular branch by considering one independent sources and eliminating the remaining independent sources present in the network. So first you have to follow the step superposition theorem. First you have to observe that in a circuit, if there is a number of sources must be there. So what you done? First you have to consider one source only, and the remaining sources will be either will be the that means either will be the voltage source, put it as short, either will be the current source, put it as the open. Next, step 2. Repeat step 1 for all independent sources present. If there is number of sources must be there, if in the circuit there is totally 4 sources must be there, first you have to consider one source. Remaining sources will be non-operative. That means it does not present in the network at one time. So when you solve the problem, you have to consider the 4 sources, but first when you solve, if there is 4 sources must be there, first you have to consider one source and remaining will be non-operative. So next you have to consider the second source, remaining 3 are non-operative. Next you have to consider third source, remaining must be non-operative. Next you consider the fourth source, remaining must be non-operative. After that, finally when you observe the 4 consideration, how you get the individual currents. Next, step 3. Add all the responses in order to get the overall responses in a particular branch when all independent sources are present in the network. So, in the superposition theorem, first step, so we find the response in a particular branch by considering one independent sources and eliminate the remaining independent sources present in the network. Next, repeat the same step for all the independent sources present in the network. Next, step 3. Add all the responses in order to get the overall response in a particular branch. So when after the completion of the, if you consider the 4 sources, the complete 4 4 times you have to solve, and then in the last you have to consider the 4 sources to get the overall response in a particular branch. The independent sources are present in the network. So for that Generally in the exam point of view, they ask write down the proof. Then you have to take in the simple circuit and put the some resistances R1, R2, R3, and to take the two voltage sources, and then consider one source and find out the equivalent resistance and find out the current, and consider other source, find out the equivalent resistance and find out then you have to add the two sources. Here I taking a simple problem and explain how this for this network how superposition theorem will be solved. Find the current flowing through 20 ohm resistor of the following circuit using 12. So here there is 4 resistors must be there. There is 5 ohms, 10 ohms, 10 ohms, 20 ohm, and one is voltage source must be there, and another is current source must be there. So they tell that first they ask find the current flowing through the 20 ohm resistor of the following circuit using superposition. So for this we have to find out the current in the 20 ohm. So you have to, there is the two or independent sources are there. So when you have to now you have to observe that. So first you have to consider one source and remaining sources must be non-operative. Next we have to consider other source, remaining must be non-operative. For this observation in the first point, suppose so now for the two, so if suppose two sources are acting alone, so from this source the current will be entering here and here the current will be leaving. For this source current will be entering here and the current will be going here. So for this first you observe the step 1. So let us find the current flowing through 20 ohm resistor. So we have 20 ohm resistor. In last when you observed here, there is current source must be there. So whenever the current, I have taken the voltage source here. So when there is a current source here, I just open circuited. Let us find the current flowing through 20 ohm resistor by considering only 20 volt voltage source. So current flowing through 20 ohm resistor. So by considering only 20 volt voltage, I want the current at 20 ohm. So first what is the principle of superposition? We can eliminate the 4 ohms. Why I am eliminate the 4 ohms? So in the superposition, so first you can consider the 20 volts and you have to eliminate the 4 ohm resist 4 amps. So that is the current. So I have to open that. So no need to write down that circuit. So 4 amps current source by making open circuit of it. The modified circuit diagram is shown in the following figure. Let us find the current flowing through 20 ohm resistor by considering only 20 volt voltage source. In this case, we can eliminate the 4 amp current source by making open circuit of it. The modified circuit diagram is shown in the following figure. So now for this 20 ohm resistor, there is only one principal node expectation ground in the above circuit. So we can use nodal analysis method. The node voltage V1 is labeled by the following figure. Here V1 is a voltage from node 1 with respect to. So for this by taking the nodal analysis or by taking the equivalent resistance also we have to find out. So when you observe here, for the 20 volts, the current is flowing here. From this, the current will be divided to 10 ohms, and these 10 ohms and 20 ohms, the same current will be flowing because these two are in series. So when it will be the parallel, will be divided. So for V1 point, the current will be divided. For the equivalent resistance, first we have to find out equivalent resistance. 20 plus 10, that is 10, 30. 30 is parallel to 10. And that parallel to 10, and this total thing will be series to 5 ohm resistor. Then I is equal to V by R equivalent. So we get the total current. But at to V1 point of view, the current will be divided. So I want the current at 20 ohm resistor. What we do? The total current into opposite resistors by total resistance. Then you get the total ohm then you get the current in the 20 ohm resistor. So that is the one type of method. So here I am telling some nodal analysis. I take simply one node will be taken. By nodal analysis, what is nodal analysis? The algebraic sum of the currents is equal to 0. So how you write this? V1 minus 20 by 5 plus V1 by 10 plus V1 by 10 plus 20, that is equal to 30. So V1 minus 20 by 5 plus voltage by current. For this V1 is related to this 5 ohm resistor and 10 ohm resistor, and these two are in series, 10 plus 20, 30 ohm resistor. So V1 minus 20 by 5, V1 by 10, V by R, V1 by 10 plus 20, that is 30. So V1 minus 20 by 5 plus V1 by 10 plus V1 by 10 plus 20, that is equal to 20. So when you get 6V1, V1 will be common, then you get 6V1 minus 120 plus 3V1 plus V1 by 130, V1 by 30 is equal to 0. So 10V1, here it is V1 by 30. Okay. 10 V1 is equal to 120. So V1 is equal to 12 volts. V1 is equal to 12 volts. We get the value of the voltage here. I want the current. So I want the current across which point? At 20 ohm resistor. So at 20 ohm resistor, what is the voltage? V1 by 10 plus 20. So I1 is equal to V1 by 10 plus 20. So substitute the value of V1 in the above equation. I1 is equal to, what is the V1 value? 12 by 10 plus 20, that is equal to 0.04. So here 12 by 10 plus 20, that is here we have 12 by 30. So 12 by 30 is equal to 0.4. 12 by 30 is equal to thing. First one, we have to consider one thing, that is voltage source. Current source will be open circuit. In this thing, let us find the current flowing through 20 ohm resistor by consider only 4 amp current source. By consider the 4 amp current source. In this case, we can eliminate the 20 volt source. So in the last one, it will be current source. So we get the open circuit, but here there is a voltage source, that is 20 volt voltage source. By making short circuit of it. So the bona fide circuit diagram is here, it will be short and we take the 4 amps. We want the current in 20 ohm resistor. So 4 amps current will be flowing here, but here the current will be dividing. So by taking the equivalent resistance, we know that for even it will comes to here point of view, 5 and 10 are in parallel. So 5 into 10 by 5 plus 10 plus 10 plus 10 plus 10, and the total will be in the form of the parallel to 20. So in the above circuit, there are 3 resistors of the left of the terminals A and B. We can replace these resistors with a single equivalent resistor. Here 5 and 10 resistors are connected in parallel, and the entire combination is series with 10 ohm resistor. So the equivalent resistance to the left terminals A and B will be 5 into 10 by 5 plus 10 plus 10. That is equal to 10 by 3 plus 10, that is equal to 40 by 3. So this is 40 by 3. So the total current will be 4 amps. So the 4 amps will be this A and B, it will be the 40 by 3. But I want the current at 20 ohm resistor. So what is the formula? According to current division rule, total current into opposite resistance by total resistance. That is, we can find the current through 20 ohm resistor by using current division rule. That is total current into opposite resistance by total. So total current is 4. So opposite resistance is 4 by 3 by 4 by 3 plus 20, that is equal to 1.6 amps. 1.6 amps. So therefore the current to 20 ohm resistor is 1.6. So for voltage source considered, to have 20 ohm resistor current is 0.4. For current source 20 ohm resistor is 1.6. So but when you observe here, for the considering of the voltage source also, the current will be flowing 20 ohms like downward direction. So this is a, by considering the current source also, it will be downward direction. Total will be entering portion. So we have to add the two currents. If suppose one will be the entering portion, one will be the leaving portion, then we have to subtract the two currents. So add the two currents, 0.4 plus 1 points, that is 2 amps current. So therefore the current flowing to the 20 ohm resistor is given by 2 amps. Not only this 20 ohm resistor, you have to find out in terms of the 10 ohm resistor, in terms of the 5 ohm resistor, like this point of view. And another example, in last I will take the DC circuits. It means there is no inductive part or capacitive part must be there, only resistance. But here I have considered the AC circuit. Here also two sources must be there. Same procedure must you have to follow. But there is the what we observed here is, it is inductive nature, it is the capacitance, and it is the resistance point of view there. So here now only we have to, first you have to consider current source, and then you have to short this source. So current source will be considered, then you have to short this is the current. So I want the current some I2, there is a current 5 at an angle of 10 will be flowing from this point. Here the current will be divided. So what is the formula? Total current into, I want the current at I2, the opposite resistance by total resistance. That is total current, that is 5 at an angle of 10. Opposite resistance impedance value J8 by total impedance J8 plus J8 minus J4 plus 3. So how much you get? Like that, in the second you consider what is the voltage source, and the current source will be shorted. So I want to find this current. So 10 at an angle of minus 60. So here the current will be flowing. Whatever the current is flowing from this point, here it will be open. So there is no need to flow that. There is no chance to flow there. So the current whatever 3 minus J4 is there, the same current in J8. So JV is equal to IB is equal to V by Z. 10 at an angle of minus 30 by J8 by 3 minus J4 plus J8. Then you get the total current. But when you consider here, the current will be like this direction. The starting the current I2 will be like this direction. Here also current will be same direction. But when you consider voltage source, the current will be opposite. So the total current I2 is equal to IA minus IB. Like that, when you consider dependent sources, so here how many sources must be there? That is one voltage source and two are dependent sources must be there. So So when you have see, one is another current source must be there, and one is dependent symbol is like this. So one is current source. So first you consider the voltage source, and the current source will be open circuit, and dependent source is the as it is. So what is the I2 current must be, what is the current of flowing to the I1, and the current flowing to the I3 is nothing but I2. So I1 plus I3 is I2. Next, so and like you have to apply the nodal analysis, and then you have to find out the currents. Like that, here also when you consider the current source and the dependent sources like this, so when you have to find out the here I1 plus I4, these two are in same direction, and I2, I3 are in same direction. Sum of the currents entering is equal to sum of the currents leaving. So I1 plus I4 is equal to I2 plus I3. So next you have to consider the three sources. Then you have to find out the total current. What is the Vx value? What is the Vx value? So I is equal to V. So we have to find out the I1, I2, I3, then that means I1 plus I3 is equal to I2. So when you consider here, by taking the one nodal analysis, you have to find out this, how much of the current flowing. Like this, I1 plus I3 is equal to I2, and I1 plus I4 is equal to I2 plus I3. So I is equal to V by R. So in this class, we discuss about the what is the different superposition theorem, what is the statement of this superposition theorem, and how to solve, what is the procedure, what is the steps to follow for finding the superposition theorem. Thank you.